that this is equal to 2. By direct calculation, 5 minus 1 is 4. The square root of 4 is 2. Okay, so it kind of makes sense. Now, the proof. Okay? Given epsilon more than 0. Let's see if that delta works.
Why are you using the minimum?
Well, let's write the proof and then we'll see. I'm giving you a delta. Let's make sure it works.
Oh.
Okay? And then I'll show you how to find the delta. Okay? When you read a proof, this is what it reads like. Okay? We want to make this less than epsilon. Let's make sure that that choice of delta actually does the work, does the trick. Okay? So what we're going to do now is, I'll do it here, we're going to multiply this by okay? Yes? And then you're going to get okay? Are we good with the algebra? Alright, so that's oops, sorry. This has to be an absolute value. So this will be an absolute value. This is always positive. Now, when delta is smaller than these two, and x minus 5 is smaller than delta, then x minus 5 will be smaller than this one. Okay? And if delta is less than 1, then I'm telling you this quantity will be less than
Is that supposed to be absolute value of the bottom as well?
well, no, well, you could, but there's always positive. Okay, so this quantity, if delta is less than 1, then that quantity will be less than 1 over 2 plus square root of 3. And what is that equal to? Epsilon. What?
Yeah.
Right? Okay, well, that's why we do the proof plan first. Okay? Because right now this looks like a mysterious statement, like where did this come from? Right? Okay. But I just wanted to show you how these proofs look when you read them in a book. Okay? And we have to be able to provide this delta using that proof plan. Well, everything actually makes sense here. And since delta is the minimum of these two, we can replace this with something larger. But what's unclear is how this quantity is being replaced by this fraction. That's the part that's unclear. Okay? And that's what the proof plan will provide. Yeah? The delta has one value. Okay, let me tell you something. Let's say epsilon equals, let's say epsilon equals 1 over 2 times 2 plus square root of 3. Right? Then what do you pick for delta? If epsilon equals that, what is this quantity going to be? 1/2. So which one do you pick? 1 or half? Half. Does that make sense? No?
Why the half?
Oh, yeah.
Minimum, the smaller one.
Oh,
Right?
okay.
This process, I can't stress this enough. This process has to work for any epsilon, okay? Any epsilon. So to test it out, I'm picking an epsilon and trying to see what's happening here. If epsilon equals this is a positive number, then do we have a good choice of delta? Does this sentence make sense?
Yes.
Well, yeah, because then this would be minimum 1 comma half, so we pick the half, right? If epsilon equals 1, what would this number be? 2 plus square root of 3, which is about 4.7, right? So then which delta do you pick? Which one do you pick for delta? 1. And this process will work. That's what I mean by delta doesn't have two values. The delta has always one value. It's the smaller of these two. Okay? We have to make sure this process works for every epsilon. Okay, let's try to figure out where all these, where this number comes from. And that's why we want to do a proof plan first. Okay, that's why we jump ahead a little bit before we write the actual proof. Okay? So, but we know what we want. And what we want is this. And in order to extract delta from there, I have to have this expression somewhere there, okay? Without square roots. So kill the square roots. How do you do that? Less than delta epsilon. Okay? Now if you multiply the numerators, you get absolute x minus 5. And then you'll get 1 over less than delta, less than epsilon. Like we said before, on the left side of this inequality, I only want x minus 5. So I got to move this over, but before I do that, I have to replace it with a number, right? And that number has to be the worst case scenario. In order for me to figure out the worst case scenario, I have to have some idea of what x is, where it is. What controls the position of x? What controls where x is? The delta, right? Here's 5. Delta tells me how far x can be from 5. Okay. So for me to get an idea of what this number could be, I need to know where x could be. And in order to understand where x could be, I need some choice of delta. Okay? That's why before I can continue, I have to make an assumption. And I usually will make this assumption. Okay? Making an assumption about delta gives us an idea of where x is. Look. This leads to this, right? Yes? Yes. Okay. That leads to this. I'm trying to get to see this quantity. Where, between what two numbers this quantity is. Okay, so I want to make this x minus 1, right? So what do? Add 4. So we get 3 less or equal to x minus 1 less or equal to 5. Yeah? Yes. Now I want a square root. Yeah? Now I want to add 2. And now I want to do what? Reciprocal. I have a reciprocal here. I don't have this quantity, but it's reciprocal. When you do a reciprocal of an inequality, the direction changes, right? Okay. So then 1 over 2 plus square root of 5 less or equal 1 over less or equal 1 over. Right? Here's why they switched. Let me just give you a quick example. 5 less than 7, right? 1 over 7 less than 1 over 5. You see that? When you do reciprocals, the direction changes. You're with me?
Yes.
Okay. What's the worst case scenario for this quantity? What's the largest it could be? 1 over 2 plus square root of 3. So I want to replace this quantity by the worst possible case and still have it less than epsilon. Okay? If I were to continue from there, okay, get this fraction eliminated, so I would have that. And there's your candidate for delta. Delta should be smaller than that. But delta should also be smaller than 1. How do you combine those two statements? And at minimum. So it's smaller than both. At some point in your proof, I'm not going to write it again, you have it. But at some point in your proof, this is where we ended up with. Something equals right? This is where at some point, this is what we had in our proof. And we wanted to say, okay, we wanted to say less than. This is less than delta, which means it's less than this. And since delta is less than 1, this quantity is less than this. So I can replace this fraction by that, 1 over 2 plus root of 3. Okay? And then we get f of x minus L less than 1. And that completed the proof.